Bismillahirrahmanirrahim. I am so glad to be part of this scientific event, the International Conference on Materials and Energies. My name is Abdelkader Medjouri. I am a faculty member at the University of Wad. I work at the Department of Electrical Engineering. So I am today here to present the main results of numerical investigations about highly coherent broadband laser source based on supercontinuum generation in nonlinear photonic crystal. Donc, in this talk, I am going to present to talk about conventional optic fibers and photonic crystal fibers and the differences between these two types of waveguides, photonic waveguides. Then I will talk about photonic crystal fibers and the subject of nonlinear optics and the various nonlinear phenomena that occur in photonic crystal fibers. In third point, I will talk about supercontinuum generation. This spectacular phenomenon that occur in optical waveguides. Then I will talk about the main results of simulating supercontinuum generation in chalcogenide photonic crystal fiber. Then I will end this talk with a conclusion. So, photonic crystal fibers are the combination of two key components: optical fibers, which are optical waveguides that are widely used in many applications, including sensors and telecommunications, and photonic crystals, which are artificial components made by two different materials, and which are widely used in many applications for guiding, filtering, nonlinear optics in solar cells, lasers, and LEDs. So when comparing photonic crystal fiber to conventional fiber, as we know, fibers are made by two materials, two regions: the core, which is surrounded by low index cladding medium to ensure the waveguiding the light inside the core. For photonic crystal fibers, they are made by air holes, which are arranged in hexagonal lattice surrounded solid core and running along the fiber length. Two key parameters that characterize any photonic crystal fiber, which are the pitch and the diameter, and air holes diameter. So, how light is guided in photonic crystal fiber? There is mainly two mechanisms, which are total internal reflection, the same as in conventional optical fibers, and the photonic band gap, which are widely found in photonic crystals. So, in the first class, we find large mode fibers, highly nonlinear fibers, and fibers with large numerical aperture. In the second type, we find low curved fibers and So, why nonlinear optics? What is nonlinear optics? The nonlinear optics is the subject in that deal with high intensity pulses which interact with medium and give as a result the generation of new spectral and frequency components. So, how to model the propagation of pulses in optical fiber? We generally use the generalized nonlinear Schrödinger equation, which simulates the propagation of laser pulse envelopes given by the function A, and to model the various linear and nonlinear parameters such as dispersion, the Kerr, and the Raman response of the medium, among many methods used to solve this equation. The range quota, fourth order range quota in interaction picture method, is fundamentally more accurate. And so what is supercontinuum generation? Is a nonlinear process in which an optical pulse undergoes substantial and considerable spectral broadening during its propagation in nonlinear medium such as solids, liquids, and these sources based on supercontinuum generation are widely used in various applications such as telecommunications, spectroscopy, and meteorology, and it gave rise to 2 Nobel Prizes in physics in 2005 and in chemistry in 2014. So in this talk I will give the numerical simulation of supercontinuum generation in photonic crystal fiber made by chalcogenide. The refractive index is modeled using the Selmayr equation as given in these figures. So the different guiding modes and the different properties such as chromatic dispersion, the mode area, and Kerr effect and Kerr coefficients are calculated based on the Maxwell's equations and using the finite difference method. So the impact of varying the core surrounding air holes on the optical properties are given by these figures. So we have optimized our structure to obtain normal regime of dispersion in which the chromatic dispersion is totally negative. So we have modeled supercontinuum generation where the spectral broadening is mainly driven by self-phase modulation and optical wave. We have also calculated the covariance, which indicate the stability of the source against the noise present in the So we have obtained after several series of numerical simulations supercontinuum that extend that span the region from 1.45 to 5.95 micrometer at the spectral flatness 20 decibel, and using only 50 millimeters of the fiber length, with a pump with pumping at 3 micrometer and using pulse energy of 3 joule. So as conclusion, we have proposed the PCF made of chalcogenide. We have used the finite difference method to calculate the fundamental mode optical properties. We have also used the generalized Noether-Dingler equation to model the pulse propagation inside the PCF core. We have obtained mid-infrared supercontinuum that cover a wide spectral region. The supercontinuum is initiated and driven by the self-phase modulation and the optical wave breaking. The proposed mid-infrared source can be used for wide range of applications such as spectroscopy, imaging, tomography, quality assessment. So for further reading, I recommend these papers about supercontinuum generation in various kinds of PCF designs and materials. At the end, I am so grateful and thank you for your kind attention.